Well, good morning, good afternoon. Thank you for joining us for our webinar today, where we'll talk about the benefits and considerations for replacing manual inspection methods with automated solutions. My name is Kathy Macbeth, and I'm the Marketing Manager at Radiant Vision Systems. I have the pleasure of introducing our speaker for today, Eric Eisenberg, who's Radiant's Applications Engineering Manager. For those of you who have worked with Radiant, you may already be with Eric. He works very closely with our customers, helping them to develop solutions for their own production facilities and processes. He has an extensive background in optical engineering, with the BS in Laser and Optical Engineering from the Oregon Institute of Technology. So before I pass things over to Eric, I just wanted to mention that we will be taking questions at the end of the presentation. You're welcome to submit a question at any time during the broadcast, and to do so, just use the question pane on the GoToWebinar interface that usually appears on the right or the top of your screen. So go ahead and submit those at any time, and we will queue those up at the end of the presentation. So without any further ado, I'm going to pass things over to Eric.
Great. Thank you very much, Kathy. I appreciate everyone joining the webinar and your attention today. So I'm going to go over the agenda for today's webinar. So we have a fair amount of material to cover. We'll be able to get through all of it. So first, we're going to just briefly touch on what Radiant Vision System is with the company. What is the opportunity that we are talking about, which is related to this subject. Then we have requirements that customers are typically going to have for our various solutions. We'll talk about the components that are included in the solution. We'll touch a little bit on how we've been able to make the technology and solution a little bit faster, better, and cheaper. And also some challenges that we typically encounter in these types of solutions. And then we'll give some examples of some various applications that we support in the field today. And then we will conclude and have some time for some questions and answers. Okay, so Radiant Vision Systems was originally founded as Radiant Imaging by Ron Rakowski. Basically what happened is Ron was running essentially a measurement services company where we were dealing with measuring luminance and uniformity and such of projectors and these types of systems. This type of measurement is typically accomplished with spot meters or luminance meters, some kind of non-imaging system. Basically to try to speed up the processes, Ron invented the imaging colorimeter and began using that to fill his measurement services contracts. Customers began to see that he was using something like this imaging colorimeter and asked if they could get one for themselves, and essentially the rest is history. We have thousands of inspection systems testing millions of displays today. We're headquartered here in Redmond, Washington. We also have a large office in Shanghai. We have another satellite office in Shenzhen and another one in Seoul. And we were recently acquired last year by Konica Minolta, and that's pretty exciting. We'll talk a little bit about what that means for the company. So we are talking about replacing human visual inspectors with automated systems. Basically, how is visual inspection done today? Well, basically it's done by humans. Essentially, there are lots of people who are working in this role, and they are inspecting very specific things. That generally what they're asked to look for is things like particle defects. This could be an embedded particle in the system that we're inspecting, whether that be a backlight unit or a liquid crystal module or a liquid crystal cell. Also pixel defects. By that I mean either a stuck pixel or a dead pixel, or a pixel that just is acting strangely. Also mura. Mura is a Japanese word. It loosely translates to blemish. Essentially any kind of problem that might be experiencing this display, basically a blob, any kind of non-uniformity that needs to be quantified and identified. Also light leakage, which essentially is a derivative of Mura. Basically it's a result of the backlight unit bonding with the liquid crystal module around the edges. Often some of the backlight unit light leaks out a little bit more than it does around the other areas, and that can cause some non-uniformity, also Mura. And then pattern Mura. So sometimes the manufacturing process introduces some kind of pattern that's visible on the display, and we may need to inspect for that. So most of this inspection is being done in Asia. Essentially, all human inspectors are generally women, age 18 to 24. Younger and women tend to have better eyes, and so this is typically how that is done, and it is how it's traditionally done, continues to be done this way. The turnover rate for these human inspectors tends to be very, very high. They typically last 2 to 4 months or so in this role, working 12 hours a day, standing and inspecting thousands of displays every day. I've reviewed a lot of human inspector results as part of this role, and I can tell you that the human inspectors tend to be quite inconsistent. Basically, every inspector may give a slightly different answer about what they see in the display, and typically there's little or no formal training for the inspectors. They basically are asked to look at the displays and see if they can find something, and they just sort of decide what that is on their own. So what is the opportunity? Well, essentially the opportunity is that we can replace human inspectors with imaging systems. So as I mentioned before, the display industry still relies predominantly on human visual inspectors. The majority of inspection is still done by humans. Basically, the measurement resolution of imaging systems that can accomplish this type of work, as well as the speed and power of personal computers that we can deploy in these factories, has reached a resolution and a speed where the inspection that's being done by humans can actually really be emulated and potentially exceeded. I like to call this the final frontier of display production automation. I've toured a lot of different factories that are making displays and components for displays in various parts of Asia. I visited a brand new one in Chongqing just recently, and after the tour I was asked a question, what did I think, what was my impression of the factory, and my response was, where are all the people? This is a factory in China. And the answer I got to that is, there are too many people. So essentially they are just trying to eliminate everybody inside of these production areas, because it's the people that tend to introduce the contaminants that we're trying to inspect for. And basically these companies that are doing this kind of automation are investing in the far future, not just next quarter. They're looking 5, 10, 20 years out. And they realize that even though labor may be cheap in our facilities today in China, that probably will not continue to be the case far out into the future. So investing in automation now is something that's really being pushed for. Even recently, we were being pushed on a program to try to accelerate the schedule, and our customer was complaining about a labor shortage, and this is in China. So what is the return on investment that we can gain here? Basically, this is my little commercial slide here, and essentially what I want to say is that when you invest in a imaging system, a visual inspection system, it does pay dividends, and it pays technical dividends and then also a commercial return. So let's just quickly touch on the technical dividends. Basically, the system training is done by an engineer essentially setting up a sequence to control the system. Once that is complete, that can be replicated, that can be portable, it can be deployed all over the place. It can be done for incoming inspection, outgoing inspection, you can send it to your vendors, a lot of different options. Essentially, there's really no variation in results and very reproducible analysis. So if we inspect the same display today, tomorrow, the next day, we're going to get the same answer, assuming the display hasn't changed. The system, obviously, it doesn't get tired, it doesn't quit, it doesn't complain, and it doesn't make the device dirty. I've seen examples where certain inspectors are known to contaminate displays heavily, maybe wearing a little too much makeup or so today. And also we can do data logging, trending, and record keeping at a level that really would be not practical when a human was actually operating the system themselves. What is the commercial return? I have pretty good examples. I have one system that we deployed for a BLU inspection. The manager there told me that it would replace 13 of his operators. And even though our systems require some investment up front, when you're talking about taking 13 people off of the payroll, the return can be pretty rapid, even at a place where it has relatively low labor costs. Obviously, labor costs are rising. And then we have focus on automation is really critical for long-term corporate viability. That's what we're seeing with our customers in Asia and around the world. And the customers who are not focused on automation are the ones that are going to start to fall behind. And then another benefit is that improved working conditions help a corporate image. Basically, no one's going to be concerned about the environment that the camera is deployed in, and so that can just help avoid any potential issues there. What are requirements? What are typical requirements for a solution that we deploy? So every solution is really unique. We have some standard tool sets, packages that we support. However, we find in practice that we typically have to tailor all of our solutions to specific customer needs. Often a lot of things can be accomplished with what we have out of the box, but the reality is that no solution is the same as another solution. Speed is just absolutely critical for this industry and for this business. The faster we can do inspection, the more throughput they can have on these lines. That saves the company's money and tends to be really important. So, we are talking about shaving, tens of milliseconds off of system tack times, and that's a really critical part of our role. Factory and system integration, generally when these systems are being deployed, they need to talk to some kind of factory system, whether that is a MES system, a CIM system, a shop floor control system, whatever they want to call it. Generally we need to talk to something, whether that be via serial, RS-232, or say TCP/IP. This is generally a requirement for the system. The display models are changing, technology is changing, resolutions are increasing, people are using systems like OLED versus LCD. All of these have requirements that are specific for that particular technology. And that really means that new and diverse measurement systems are needed. One of the exciting parts of the acquisition from Konica Minolta is the fact that we have a much broader portfolio of products that we can offer for our solutions now. That was part of the Konica Minolta family. So what are the typical components of a solution that you would get from Radiant Vision Systems? Well, I have basically everything pictured here. An imaging colorimeter is generally a key component, but it's not necessarily required. We also have spectrometers, color analyzers, and other types of instruments that can do visual inspection. You need some kind of software package to control all the devices and automate the process. And generally, you need a team of experienced application engineers who have a lot of background doing this type of deployment. And I would say that we probably have the best engineering team in the world to do this type of work. I mentioned a little bit about faster, better, cheaper. So we'll just touch on that. Basically, Radiant has really worked to make us into a production imaging company. If you have experience in the past with Radiant products and solutions, a lot of the more original systems from, say, 10 years ago were really designed for R&D purposes, uses in a laboratory. Speed was not a critical component to the systems. Now it is absolutely one of the criteria that we need work to improve. So we have imaging systems today that can produce a measurement, which is essentially taking a picture, and we can get that data to the PC for processing in approximately 300 milliseconds or so. How have we done that? We used very high resolution CCD devices. We've enabled what's called quad mode, so we can access the data from 4 different sections of the CCD simultaneously, so that it really increases this time or reduces the time that it takes to be able to read the data off of the sensor. And getting the data from the imaging system to the PC, that also is a lot of data, so implementing gigahertz Ethernet is a way to really get that data quickly over to the PC. we have the full suite of Konica Minolta instruments available to us now. So instruments like the CA310, which is a color analyzer, can take up to 20 samples per second. Faster computers, multi-core processors are basically standard today. Our software is fully multi-threaded to take advantage of multi-core processors, so the more cores that you can put into the PC that's doing the inspection, the better. And then a lot of different creative solutions to try to make the system faster. Algorithm optimization, multi-channel throughput. Essentially, we can measure multiple devices at the same time to drastically increase throughput. And then also distributed processing. If we have a lot of image processing that we have to work on, we can do that processing on multiple PCs. Better solutions. Radiant generally, when production environments, isn't just selling a camera system, we're selling a full solution. We tend to call this a fixture, which is what's pictured on the right here. Basically, this is a machine that goes into the factory that talks to the shop floor control system, the MES system, contains the camera, multiple cameras potentially, and has an interface for the operator to start and to load the device, that kind of thing. We've done inline and offline inspection with these types of machines, fixtures. We've written to flash memory. The report generation capability of the software is quite good and can be highly customizable. And then we've made a lot of improvements for the interface for the operators. Basically, technologies are changing, and we have a lot of different solutions that we can deal with those different technologies. Cheaper solutions. So essentially, with a wider portfolio of products, we can really tailor a solution for our customer's budget to try to meet the requirements and also be affordable. The spectrometers and color analyzers are applied to this. Basically, the less expensive the investment, the higher return. And we really are a quality supplier. If we say we're going to execute on the solution, we execute on it and we get it done. What are typical challenges that we can encounter? Well, humans are really highly adaptable. They can move about. They can hold a device. They can look at a device at an angle. So how do we deal with that? We can use multiple cameras, potentially use moving parts. A spotter sniper solution, basically we do a wide inspection and then essentially zoom in on an area that potentially has an issue to take a closer look at it. And then there's other ways to use calibrations and such to make equivalent inspection without actually having to look at an angle. We have unique specific solutions are needed within a short development window. We don't have a lot of time to deploy these things. Our customer schedules are very aggressive. We're able to really work around the clock by having our Asia engineering team, Chinese engineering team working with the customers. If they identify issues, those can be solved overnight, China time, by U.S. engineers, and solutions can be deployed the next morning. We spend a lot of time in the field working directly with the customers. So rapid turnaround is just absolutely critical. And then solutions need to continue to be upgraded as technologies improve. Tech cred is something that a customer I had talked to me about a lot. So it really is about us understanding the technology, having that expertise, and also earning the customer's trust. So let's go through some examples of some kinds of display inspection that we typically do. Display uniformity test is one of the most common, basically testing the luminance and uniformity of a display. And then we also have a little example here of RADA, Register Active Display Area, on the left, and then various pass-fail criteria. So for the RADA example, you can see that I've identified the four corners, 1, 2, 3, 4, of the device. Essentially, we're able to rotate the image and crop the image out so that we can only analyze the active area of the display. We don't need a really high tolerance on the fixture because the display can appear in front of the camera a little bit different every time, and we can deal with that. And you can see the result on the right here of the uniformity test. We've created what we call a synthetic measurement, which essentially is just looking at the average luminance of a number of regions of the display and turned that into a new measurement that has a lower resolution, but each pixel is representative of those sections. So in this case, we've set a criteria so that this 47% luminance is a failing result, but the 82 nits as average level is actually a passing result for this display. So those thresholds can be set as part of the configuration of the test. We'll go through a particle pixel display testing example here quickly. We have a measurement that we've taken of a device, and you can see that maybe there is something going on here. We generate what we call a local contrast image, which essentially highlights any rapid changes, rapid luminance changes in the display. And then we can threshold that image and identify where these problems exist. So we have a number of potential dead pixels or particles that were present on this display that we've identified. If we need to know the exact coordinate of these defects, we have another technique that we call pixel defect detect, and I'm showing that on the right here. Essentially what we do is we turn on one pixel and the surrounding pixels are off, and we are able to march the pixels across the display and is able to image every individual pixel. We register on those, and then we sample every pixel of the display, and we turn it into another synthetic measurement that actually is at the real resolution of the display that we're inspecting. So now we would know the specific pixel coordinate of any problem pixel that was identified. We have new types of displays that are coming out. Radiant is on top of that. We're developing technologies. We have technologies now that can do inspection of virtual reality VR systems, augmented reality AR systems, and displays are showing up all over the place and they need to be inspected. And we talked a lot about human replacement, but the imaging systems that we're talking about here can do more than that. Things like gamma correction or white color balance. And then demura, we're able, when we measure the individual pixels, we can actually come up with coefficients that turn a display from non-uniform to uniform, and that becomes really critical for especially OLED. All right, so in conclusion, there really is a convergence happening here of this imaging colorimeter technology, the algorithms that have been developed, the computing technology that has really made it possible now for human visual inspectors to be replaced. This has been a dream for a lot of system automation people for a long time. Often it's a nightmare because they receive a box and a manual and they have to figure out how to do it. That's not how Radiant operates. We sell a solution which includes us helping to make the system work. And that's why you really need a dedicated partner with the right portfolio of tools to succeed in doing automation of visual inspection. Being able to integrate the full suite of Konica Minolta technologies means that we can save costs, we can save space, we can make the systems faster. And today we have thousands of imaging systems inspecting millions of devices, and every deployment has multiple different test requirements. So we have a ton of experience making these systems operate. All right, that is it. Are there questions?
Yeah, thanks, Eric. So we're going to open it up for questions now. As I mentioned earlier, if you'd like to submit a question, you can do so on the questions pane on the right-hand side of your screen in the GoToWebinar interface. I'm going to start by answering the first question, and that is, can I get a copy of this presentation? And the answer is yes. You will be receiving an email within a few days, and it will have a link to a recorded version of this webinar as well as the slides that Eric is using. And I do see we have some questions coming in, so I'm going to let Eric respond to these.
Okay. All right. The first one I see is how large of a screen can be imaged. That really is dependent on the resolution of the device. We have a lot of different optical solutions, different kinds of lenses for the imaging systems that can adjust the field of view of the camera to be appropriate for the setup that we have. Okay, let's see what other questions are there. What is the cycle time? Basically, that can be really dependent on the application. I have one deployment where the throughput is essentially 10,000 backlight units per day. So 2 or 3 seconds is probably typical for that inspection system. Sometimes the solutions are more complex, and that requires a little bit more processing time. see. Bottleneck for time is the filter wheel. Will it be removed with another feature to measure color faster? That's an interesting question. We have systems that do not use filter wheels. There is the Y camera system, which has only a photopic filter. So that is one of the faster systems. And there are other technologies that Konica Minolta supports that can measure color without a filter wheel. So if color is the requirement and speed is absolutely needed, there are some options that could be discussed. See how much factory floor space is required for each test cell. Again, that's really dependent on the size of the system that's being deployed. What I've typically seen is maybe 4 feet by 4 feet would kind of be the footprint of the machine, and then it tends to be relatively tall. It just really depends on what's being inspected and the working distance that's required. Examples of what test systems Radiant can do for near-to-eye display. That's interesting. Often MTF is really critical for these types of applications, so that's something that we certainly are able to look at. Also, uniformity has tended to be a real issue with a lot of the devices that we've inspected, so uniformity tests are typically done. And then also potentially demura. We might be looking at an OLED device that be used for the near-to-eye application, and that OLED may not be uniform, and the customer may actually want to try to correct the device. Okay, so I see that there's a question about application engineers would help with the deployment, how much assistance will be provided, hands-off, complete installation and training. Basically it's really up to the customer. We tend to handle a lot of the solution. So, we will go on site, we will deploy the system, we will work with your vendors to help integrate to whatever systems are being used on the production floor. And then we also offer a lot of different training packages to be able to get the personnel up to speed, especially with China, our on-site support with over 60 engineers over there. They spend all of their time working directly with the customers and helping with all of our different deployments. I see there's a question of expected lifetime of the device. Basically, I would expect it to last for a very long period of time. We recommend a yearly calibration cycle, but we have systems that have been operating for 10 plus years in the field today. Let's see, is Radiant moving to CAM imaging equipment, or are you still making your own camera systems? I would argue that our imaging systems are probably the best of the Konica Minolta imaging systems available in the family. Some may not agree with me, but that is currently the plan. We continue to develop and manufacture our imaging systems and support them, but then we also have the ability to support and integrate all of Konica Minolta's family of imaging systems and other types of sensors. Okay, I see there's one with what's the upper and lower display size limits for the inspection system. I touched on this a little bit earlier, but basically I would say there really is no particular limit. We've done inspection of essentially LED boards and sports arenas, and we've also inspected micro displays that are, the size of your thumb.
Okay, I think we'll wrap up right there.
Great.
I see we have a couple questions we didn't get to, but we are at the close of the presentation. We will follow up with you directly if we didn't get to you. And also I'd like to encourage you to contact us at the info@RadiantVS email address if you have a question after the presentation that wasn't answered, and we'll make sure that gets routed to the appropriate person. So on behalf of all of us, I'd like to thank you for your attending today, and as I mentioned, please feel free to follow up with us if you have any more questions. Thank you.
Thanks again, everybody.